Example 6, evaluate exactly, which we know probably means that we're supposed to be solving this with the unit circle. But 105 degrees is not on the unit circle. But given the fact that we were just given these formulas for the half angles, what is 2 times 105? Right, 2 times 105 is 210. Right, looking at the unit circle, is that one of our unit circle angles? Yeah, it's right there, 210 degrees. So if we use our half angle formula to write it in terms of twice the angle that it is, then we'll be able to solve it. Right, so we go back here, and the formula is, again, remind yourselves, remind me, 1 minus cosine over 2. So it should be plus or minus 1 minus the cosine of 210 degrees over 2. Now, the cosine of 210, we look at it, it is negative square root of 3 over 2, the x-coordinate. So we can plug in for that, plus or minus 1 minus negative square root of 3 over 2 divided by 2. Right, which equals plus or minus the square root of 1 plus the square root of 3 over 2, which is plus or minus, find a common denominator in the numerator, right? That'll make that 2 over 2, or 2 plus the square root of 3 over 2, which is plus or minus the square root of 2 plus the square root of 3 over 4. So we could actually simplify that, right? The square root of 4 is 2. So that we'll be able to take that out. Plus or minus 2 plus the square root of 3. I should have written that different. That is 2 plus the square root of 3 over 2. Right? And that's exact. But it's not very often that you see a square root inside of a square root. Now, the last thing is we'd have to say, well, which quadrant are we in? The sine of 105 degrees. 105 degrees is which quadrant? It's in the second. So we would expect the sine to be positive. It's above the middle, so it's positive. So we go back here and we can say we are choosing the plus.